Hello, welcome to IPDay's Wednesday webinar. Today we are going to be talking about the third out of three essential algebra skills. We're talking about solving linear equations and inequalities. My name is Kate Redman. I'm an IPDay subject matter expert. This is my second year working with Florida, and it has been super fun. I am also the founder and CEO of Light and Salt Learning, and what we do is we provide support for struggling students to help them to pass their GEDs. So I get to work with a lot of students to learn algebra, especially those with learning disabilities, educational trauma, other significant learning struggles. And so, as you can imagine, in the course of doing that, I've learned a thing or two myself about teaching these skills to struggling students. All right, some housekeeping today, some things to remember. If you have a question, you can actually type it in chat. It's a lie, guys, but I've got the chat open so I can look at that. We'll have someone monitoring that as well if you have any tech issues or anything of that nature. So go ahead and use the chat, and I'll be asking you questions a couple of times during the broadcast. Your microphones are unmuted, so you're going to be in listen only mode. Cut down on all that background noise. And today's presentation is going to be recorded. Already, if you go on the IPDay website, you'll find the materials for today's presentation. We've got the PowerPoint. We've got a handbook for you with some other goodies. And then in the next 48 hours, you'll see this recording of this presentation go up as well. All right, so agenda today, what are we talking about? We'll be looking at the basics of solving linear equations and inequalities, looking at the component skills individually that students need to have, and then we'll talk hitting the freeway, how to put those skills together so that students can graduate to being able to solve multi-step equations and inequalities. We'll talk about how to equip them for that, what can be a scary ride as they try to attempt these multi-steps, and by directly teaching them navigation tools. And then we'll review quickly those three essential algebra skills and how they fit together and how you can practice them all together in your classes. Let's start with those basics, the component skills of solving. So first of all, what do I mean when I say solve? Solve is not just a generic word that means find the answer in mathematics, and it specifically means to find the value of a variable that makes the statement true, to find the missing solution that that variable is standing in for. So for example, to solve the equation 3x equals 33, that's answering that question, what value of x when multiplied by 3 gives 33? And of course, as you all know, if I were to answer that question, I would answer in a complete sentence another equation. X is something. What is x? X is 11. That is the solution I have solved. Wonderful. So let's look at what kinds of equations we see on the GED. Today we're focused on linear equations, and I just want to make sure that you guys know the terms I'm using. So we're only going to really focus in on linear, but what do I mean? First of all, the majority of the linear equations on the GED that you have to solve, I should say, are in one variable, meaning there's just one letter. And it might appear more than once in the equation, like you might see an X on both sides, but it's still only an X. If you do see an equation, for example, y equals 2x plus 3, we could see that in the context of graphing, but that's not what I'm talking about today. I'm talking about solving for a specific variable. They do also have literal equations occasionally on the GED. They could come up in science or math. And that is when, for example, D equals RT. They could ask you to have this equation with no numbers at all and have you solve for T. But even if they did that and they had multiple variables, you'd still just be solving for one of them. You're not going to find the value of each one of those variables, if that makes sense. So, another thing to know about linear equations is there's no exponent on the variables. This is in contrast to quadratics, the other kinds of equations we're going to solve. So you will see an x, you can see 3x, negative 3x, but you're not going to see a square on a linear equation or a third power or a fourth or anything else. We're not going to see an exponent on that variable. And these types of equations are nice because we can solve them using inverses exclusively. Totally just by using opposites, we can isolate that variable, get it by itself, and solve the equation, find out what the variable is equal to. And I hope you guys know what I mean by inverses. I'm talking about opposite operations. So, for example, the opposite of, say, multiplying by 3 is dividing by 3. The opposite of adding 3 is subtracting 3. So you might say, Kate, I thought we were talking about types of equations. We're talking equations and inequalities today, guys. I just didn't have enough space up at the top to write types of equations and inequalities. But here's an example, a very typical GED style example of an inequality, a multi-step inequality your students might need to solve. And this is linear. Again, we can see just the one variable and it's only to the first power. And we can totally use opposites to solve this. Another example is this 3 times the quantity x plus 8 equals 8x minus 27 minus 2x. Complex again, but this is still one of the simpler styles of equations, linear equations. Now, oppose that to a quadratic equation. This is not the focus of what we're going to do today, but do these show up on the GED? Yes, they do. The quadratics on the GED are also in one variable. But in this one, the highest power on an exponent is a square. Like, for example, you could have 3x squared plus 5x minus 27. I'm not checking my work, so I don't even know if this one has a solution, you guys, but equals 0. That would be an example of a quadratic. And if you have something like that, it can only be treated like a linear using pure opposites if there's no x term. So here's a great example. Negative 4x squared is equal to negative 36. This has no plain x term. It only has an x squared term. So I could use some opposites to solve this guy. This actually does come up like in the case of when you're solving with the Pythagorean theorem. But we're going to be able to use today's methods in order to do that one because when we plug into the Pythagorean theorem, basically what we end up with is we only have a square term. So for example, I'll just give you an example. Let's see, you'll end up with an equation like 25 plus b squared equals 49. And then from there, I don't have a plain old b term, just a b squared term. And so I would be able to solve this using what we'll talk about today, the plain old inverses. Otherwise, if you do have like an x squared and an x term, students will need more tools, such as we talked about this if you were with me for Essential Skill 1, the formula, the quadratic formula that's on the formula sheet. So an example of that, yeah, 3x squared plus 5x equals 2. I would not be able to use straight inverses like we're going to do today to solve something like that. I would need some additional skills. And there's 4 different ways students could solve those. But those are not the majority of the problems on the GED. Now, there's also systems of equations. I will admit that to you as well. Those are a little different than linear. So what am I talking about? I'm talking about when we have 2 or more variables, but you also have 2 or more equations, like 2x plus 3y equals 15 and 3x minus y equals 10. If you had something like that, you would need additional skills, but I have good news for you. In general, on the GED, those are multiple choice word problems, so you can use a guess and check method. So we don't have to get deep in the weeds on those either. So all of that to say, this is my defense for why the biggest skill that our students need is solving linear equations and inequalities rather than any other type. All right, here we go. Let's talk isolating variables using inverses. So this is that main skill that I said we were going to use. So I know that most of you guys know this, but I also know we have teachers at really varying degrees how long they've been teaching math. And sometimes you know what you're doing, but you don't have the language for it. So I'm just going to treat it pretty basic here. But our goal when we're solving linear equations is to isolate the variable, to get that letter alone. And this is the important thing. This is really the key. I always joke with my students, the day you got the equal sign, you got the power to do literally whatever you want. As long as what? As long as you maintain the relationship. So, like, for example, if we're talking about an equation, I'm saying the left-hand side and the right-hand side have to stay equal. As long as those two sides remain equal, you can literally do whatever you want to an equation. Now, that doesn't always mean everything is the best thing to do. Sometimes things will take you on a long circuitous route to solving or get you nowhere. But nonetheless, you have that freedom. You have that permission to do whatever you want as long as you maintain that relationship. In the case of an equation, it's in a relationship of equality. I have to keep my left-hand side equal to my right-hand side. And then in the case of inequalities, I just have to maintain that it, like, for example, if the left is less than the right, we got to maintain that similar relationship between the two sides. We cannot break the relationship between the two sides. All right. And we're going to use that power. Obviously, this is when we start using that inverses to get rid of math. Some of us say to cancel math, where I think of it as the variable is standing its ground. That letter stays where it's at, it stays put, and the operations working on the variable are counteracted or undone to remove the numbers so that the letter can stand alone. Okay, so here's a really good rule of thumb. We talked about the component skills. So one of the component skills is to isolate the variable, but another component skill in solving multi-step equations is actually simplifying. You have to be able to simplify expressions because what is an equation or an inequality? It's simply an expression that's in a relationship with another expression. Now, of course, in the case of an equation, that relationship is equality. But in the case of an inequality, that relationship is could be less than or equal to, greater than, so on and so forth. But it's a relationship between expressions. And as we've been talking about, if you've joined me for the other two sessions, we can simplify expressions. Well, so that means simplifying can show up in the world of solving. And so it is a very good rule of thumb to simplify before we start solving. Or as I sometimes say, pack or clean before you pack. I mean, let me say it again. I don't say that. I say pack before you move. All right. It's important to remember that simplifying is one-sided. So we said it was expression equal to expression. When we're talking simplifying, we're just going on one side. You simplify the left-hand side separately from the right-hand side. And then once that's done, that's when we start using those opposites, those inverses, to cross over the equal sign. That's the two-sided math. Beautiful. So here's a great example. This type of pretty simple example where we can have some simplification comes up rather early for students because you might recognize it. This kind of looks like I've plugged in some values into the perimeter of a rectangle formula, and that's exactly what I did to get this. But before a student would start solving this, I would encourage them to take a look at both the left and the right-hand sides and look to see if there's any straightforward math you know how to do, any simplifying. So of course, there's nothing to do on the left-hand side. I don't have any operations there at all. But on the right-hand side, we can see even though we can't multiply together 2 and W, since we don't know what W is, we sure can multiply together 2 and 38. And that's what I mean about simplifying before you're solving. I would encourage your students to do that. 2 times 38 is 76, plus 2W, that one-sided simplification, before we start the process of isolating the variable, working to get the letter alone. All right. Now, That's all well and good to say. I can say to you guys, oh, well, I want your students to simplify before they solve. But there's a little bit of a problem, and that is simplifying and solving are exact opposite in every way. And so here I am in the same problem, asking my students to follow two completely distinct and opposite set of rules. And students will mix up when to do what. So it's important that it's really distinct for students that they understand that there's two playgrounds in algebra. There's two whole sets of rules based on whether we're using those inverses we're solving or we're doing that straightforward simplifying. So the first, of course, is performing the indicated operation, simplifying. And then the other is using those inverse operations, that's solving, to undo or cancel operations. The rules to those are exactly opposite in every way, right? So the simplifying, like we said, is one-sided. The solving is two-sided. The simplifying, we obey the signs. If it says plus, we add. If it says multiply, we multiply. And then suddenly, all of a sudden, we launch into doing opposites, right? It says multiply and we divide. It says add and we subtract. And that's a real brain shift for students. Like, why did the rules suddenly flip on me? And your students tend to relate it to because there's an X, the rules flip. And that's not why, right? We see simplification with X's and we see solving. So it's important that they understand what they're doing. And then even the order of operation flips. A lot of even teachers don't realize this. But when we're simplifying, we work that order of operations forwards, right? Gemma is the abbreviation I use for it, but we do groupings, then exponents, then multiplication and its inverse, division, and then finally addition and its inverse subtraction. But we're going to do that in the opposite order when we're solving, right? We take away anything adding or subtracting first, then anything multiplying or dividing, then any exponents, and finally we save groupings for last. So sometimes I say you have to free the groupings. So things for us to remember, for our students to remember, both of those skill sets, like we said, are used when you're solving those multi-step equations. And sometimes you even have options. There's so much freedom when you're solving equations. Let me show you what I mean. Here's a great example. 3 times the quantity 5x minus 7 equals 39. Now, I know how most people do this. Most people follow that lovely wisdom principle like I was talking about, and they simplify first. They take a look at that left-hand side of the equation where we see 3 shoved up against 5x minus 7 and say, oh, look, there's some simplifying, some straightforward math I know how to do. I know how to multiply 3 by a grouping. I can just pass it out using the distributive property. So 3 times 5x is 15x. 3 times negative 7 is negative 21. And of course, that's equal to 39. And I'm just going to finish up solving this here, even though I know most of you guys know how to do that. But it's because I want to compare something with you. So adding 21 to both sides, now I'm using opposites because now I'm moving across the equal sign. I get, what is that, 60. And then again, moving across the equal sign, getting rid of math, I use opposites. So dividing both sides by 15, I'll get x is equal to 4. So in that case, I simplified first and then solved, but that's not the only way to go about this. I could have done pure inverses as well. And I would encourage you to just go along with what your students do because either way is totally true and right. Let me show you what I mean. So rather than using that multiplication, that 3 times that quantity, I can also undo it. I can get rid of it. And remember, I said when we're solving, we work the order of operations backwards. And so I'm going to save any groupings for last. So I'll save that 5x minus 7 for last. And I'll get rid of the 3 by doing the opposite. What's that 3 doing with that grouping right now? Well, it's currently multiplying. So I'll do the opposite. I'll divide. And of course, I can do whatever I want as long as I do it to both sides. And what's my new equivalent equation? Well, multiplying and dividing by 3 cancel. 5x minus 7 is alone just like I wanted. Look, I freed the grouping. And 39 divided by 3 is 13. And now I have a two-step equation I can solve. A different one than the last one, but it had better get me to the same answer. So let's see, adding 7 to both sides, 5x is equal to 20, dividing both sides by 5. Indeed, I get x is equal to 4. And so we can see that we have these options sometimes. Am I moving forward or am I moving backwards? And your students need to know what they're doing, when they're doing it, and why. Okay. Nifty, nifty. And by the way, if any of you guys use my website, we have a website with tons and tons of free goodies. I teach both ways, but I only teach that second way we talked about to experienced and advanced students when we're talking about 2 and 3 step equations. An experienced or an advanced student is just fine doing it either way. Okay, otherwise, my students don't see that at all until they learn distribution. Okay, so next skill that they need. So we need to be able to simplify, we need to be able to solve, put that together in the same problem. What else do we need for solving multi-step equations? We need to know how to cancel variable terms, get variable terms to the same side. And it is important to remember we're talking about crossing. We're talking about crossing an equal sign if we talk about getting variable terms to the same side. And so it's always going to involve an inverse. We're going to move the entire term, not just a coefficient. So we must add or subtract. So here's an example of what I mean. So I'm saying this is the case where I have x's on one side and I have x's on the other side. Obviously, I need to get those x's together. I say x needs to pick a side before I can get the numbers to go away, right? If x is on both sides, it's not going to do me any good to try to isolate them. So I need to get those guys together. Now, I know you know, because y'all in the adult education classroom, we see our students all the time. A lot of times the instinct for students is to go straight to, for example, dividing. They're like, oh, I'll divide away that 11. But obviously that's not what needs to happen here. And the reason why, like I said, up here, hold on. Like I said right here is we're taking away the entire term. So students need to realize why all of a sudden the rules seem to flip and why we're not dividing, we're subtracting, but it's because we're taking that x with us. We're not breaking that multiplication bond between 11 and x. We're breaking up the term 11x from 15. We're taking it away from 15, not from x. And that is why we have to add or subtract always with terms. And then now, of course, once I get them to the same side, so let's see, 7x minus 11x is negative 4x. I forgot to change colors, you guys. Minus 9 equals 15. And now we have a regular two-step equation that we can solve with pure inverses. Okay, so now we talked about the component skills. Now, when we go to put those all together, that can be really confusing for students. You will have a student who's able to do each one of those skills individually, but as soon as we get into the land of solving multi-step equations, when you sometimes have to simplify, you sometimes have to get the variable terms together, you always have to do some kind of isolation and everything's mixed up and they're not sure which tool to pull out. That's when they really get confused. And I do compare it to my students as well as driving on the freeway. I tell them, look, it's one thing to practice changing lanes and to practice adjusting your mirrors and looking over your shoulder and accelerating and decelerating and all the things that you do. But it's a whole nother thing to when you're learning to drive to all of a sudden hit the freeway and you're doing it all and you're doing it really fast. And that is confusing and it's scary. But the thing is it doesn't stay confusing and scary. And students need to realize that. You know, the first time I went on the freeway in Arizona, I was so white knuckled because in my entire adult life, I had never gone 75 miles an hour because I grew up on a little bitty island where you were lucky to go 55 without the traffic. Or with the traffic that was there and the speed limits that were there. And so I was just absolutely petrified. But nowadays, you guys, I'll go 90 down the 101 in Phoenix. Phoenix is the nearest big city to me, you know, eating a banana and doing my mascara, all kinds of foolish things because it has become second nature. And that's where your students need to get with solving these multi-step equations. So yeah, mastering the component skill is not the same as mastering the composite skill. So it is really important then that we start with that clarity and that explicit instruction in when to do what. They need to know why and when they're moving forwards, why and when they're moving backwards, why and when they're using the opposites, and so on and so forth. And again, they need to practice until that skill is second nature. They need to be able to get on the freeway without the white knuckle driving. And they need to be able to do that before test time because test time exacerbates anxiety. So, how do we get them to be able to do that? We're going to equip them with some navigational tools. Okay. I like the structure of the three wisdom principles, is what I call them. But I'll just say to you guys that these are not rules. Okay. This is important to understand uh, that I'm not talking rules because the deal is we really do have freedom. Your students are going to learn a lot of freedom when solving equations. And the higher they get in mathematics, the more tricks and tips and different routes they're going to learn and they're going to get under their belt. However, until they reach that level of competency, these three wisdom principles can help your students have a framework of organization to not get lost in multi-step equations. So what I tell my students is do these one, two, three things in order. First thing, we simplify the left and right-hand sides separately. We do whatever work we can on the left, whatever work we can on the right. And you're going to have students who, well, actually, I'll get to that in a second. Next wisdom principle is get those variable terms to the same side. If we've got an X on both sides, that's a problem. So get them together. So I tell students, look out for, do you have a problem? Are your X's taking up both sides? Do you need to get them together? And then finally, the last step is that process of isolating the variable using inverses. That's technically the solving part of solving. Okay. Now, we've got to teach our students some navigational tools a lot of time for these students who struggle with symbols. This is going to be a big issue. So here's how to help, some ways to help your students from getting lost while they're solving these. First one is just a line through the equal sign. I start this really early. Oh, actually, let me give you a great example. Okay, this is a relatively simple example that a newbie student or a struggling student will often have challenges with. Why? Because they see that the letters over there on the right-hand side, and all of a sudden they don't know what to move where. They're moving the 15, all kinds of crazy things happen. I really, really like employing right from the start. Just a line through the equal sign. So right from the start, your students are trained to see that there's a left-hand side of an equation and a right-hand side of the equation, and those are two separate expressions. It cuts down on trying to simplify across the equal sign. It also cuts down on overwhelm because they're able to examine one side at a time, and it cuts down on those mistakes that students make when my variable's over on the right-hand side. A lot of my students like that and use that. Also, it also reinforces that idea of an equation as a balance beam scale because there's the what is that called? A fulcrum, you guys? You guys can type it in chat if you're smarter than I am. I think it's called the fulcrum of the scale. What everything balances on, that line kind of helps give a visual to that. The next thing is blocking. So I'll give an example of a case where I might use blocking. If I had, for example, 2x plus 5x is equal to 3 times x plus 7. An equation like this is easy for a struggling student to get lost in, especially if they have any kind of a symbolic processing issue, they have any kind of a learning disability. It's just complete symbolic overwhelm. So after drawing that line through the equal sign, you can literally block off one side or the other of an equation. And so I'll encourage struggling students even to hold a piece of paper up on the right-hand side, completely ignore the right-hand side, isolate the left, and just look at the left. Is there any straightforward work you can do there? Any simplifying? And of course, a student who's learned to combine like terms would say, oh yeah, I can put together 2x and 5x, and that's 7x. And then great, awesome. Now I'll do the same thing on the other side. and completely block off the left-hand side with a piece of paper or my hand and ask students to examine the right on its own. And it's that idea, again, of reinforcing that idea that um, when I'm simplifying, I'm only looking at one side. I never simplify across an equal sign. So yeah, that would be 3x plus 21. And then we'd continue going from there. And I just keep doing that to my students. I'll keep, because some of them, it takes more steps than this to simplify it. And I just keep blocking it off, blocking it off, blocking it off, and saying to them, is there any other straightforward math you know how to do on the left-hand side? Is there any more straightforward math you know how to do the right-hand side? And it's not until they say no that we move on to that next wisdom principle. Pardon me. All right. Next, another big thing that can help your students, and it sounds silly, but it's alignment. Just staying in the same order you were in. So it starts early. Like, for example, if I was solving something like 25 equals 5x, and then with a beginning level student, and they divided both sides by 5, and they said, okay, x is 5, and they suddenly flipped to x is 5. I would actually encourage them not to do that. Now, I know an inexperienced or an advanced level student is fine flipping around, but I want that alignment for a beginning level student that when they get lost in the symbols, they're able to look straight up to see where it came from. Right now, I can't do that. My things flip sides. So if I'm looking for, wait, where'd this number come from? What did I do? What happened? And I go to look up, I'm not going to be able to find it. So it's just a really good habit right from the start to have your students simplify straight down. So of course, 25 divided by 5, the 5 would be on that side, and 5 multiplying by 5 and dividing by 5 are opposites. They cancel, so x is alone. And x equals 5 is the same as 5 equals x. I would stop right there. Now, will I explain to a student that those two things are the same? Yes, but I would encourage them to write that way so they don't get lost in the symbols when things get more complicated, which, of course, you and I know things are going to get more complicated. And so staying neat and tidy and aligned progresses way past this, of course. Wherever you're at, the neater that students can be about where the numbers come from and staying in alignment. I want those equal signs especially to stay lined up. And I want to be able to see what I simplified right underneath, what falls down right underneath. Again, that idea, I tell students all the time, when you get lost in algebra, you just look straight up. You just look straight up. Well, if they're not used to keeping things aligned, looking straight up is going to fill them. All right. You've already seen me do this, but I would highly encourage you to do a different color for your each equivalent equation as opposed to your balance change. So I'll model it one more time. Let's do a simple example so you don't have to put up with me solving all the equations in the world. But if I had an equation like this, of course, we said our first rule of thumb is to simplify before we solve. So when I simplify, I end up with another equivalent equation, so it's the same color. But once I start the solving process, once I start using inverses, that's when I will use a different color. I really want that visual signal to my students that now is something I'm doing. I'm making a change. And because I'm making a change, that's why I need that balance. That's why I need to do the exact same operation with the exact same number on both sides. And that color is a good signal that, hey, something's changing here. And then I just switch back to the original color in order to write the equivalent equation. So of course, adding 14 and subtracting 14 are opposites. They cancel. 2x is alone, just like I wanted. And 28 minus 14 is 14. And now again, I can flip colors to talk about dividing away the 2, doing that opposite. And I would come back to black, except for you guys, I didn't write small enough. So pretend it's black again. But I need you to be able to see what I'm doing. So I would go back and forth between the two colors, one for the equivalent equations, and I usually use black for that one or my primary color because in the end, that's the only work we have to see. This is the only required work is the equivalent equations. When they go into college, they're not going to have to show their balance change. Now, is it a really good idea for them to show their balance change until they're skilled? Yes, absolutely. It sure is. However, it's not mandatory. So it's also a nice transition because it's really easy then for them to graduate to the point where they're just operating in the black and they don't have to see the orange anymore once they get nice and skilled. Hopefully, not in my classroom in college. And we want students to practice all of these. If a student finds it useful, we want them practicing it. We want them doing it. So it needs to get reinforced in the classroom long before testing. They're not suddenly going to be able to pick up something on test day that they haven't been using all along. And like I've said before, test day increases anxiety a lot. Anxiety increases all the symbolic processing issues. So students are more likely to get lost. They're more likely to need these things. So you might say, "Oh, this student doesn't really need any of these skills because they're doing well in class." Well, you know, you have those students who do well in class and then they go in and fail the test. Why? Because their anxiety was high, which then exacerbated their symbolic processing issues. They started dropping symbols they would not usually drop, getting lost in ways they would not usually get lost, and you didn't teach them the navigation tools because they didn't need it in the low pressure setting. And so I would encourage that you give these tools to all of your students, even if it seems like, hey, this person is fairly skilled, and let students practice them and adopt them before testing. All right. So obviously, flipping rapidly between those two playgrounds of algebra confuses even the most skilled students. We talked about going back and forth between simplifying and solving. So I have a little way that I will sum it all up for students to summarize the rules. I spell out that order of operation, mnemonic that I use for the order of operations, which is GEMMA. And of course, GEMMA, the G stands for groupings, like exponents, or like, sorry, parentheses, brackets, tops and bottoms of fractions, insides of radicals. There's all kinds of groupings. And next we have exponents, which is insides of, or I'm sorry, which is the radicals themselves and the little floating powers. Finally, multiplication and its inverse division, and addition and its inverse subtraction. So, whoa, my hand and my brain just had a fight, you guys. Subtraction. All right. And so I'll tell my students when you're simplifying, we do this forward. And when we're solving, we go backwards. And that's the little diagram I draw. I like it. I even have one for you guys. It's in the handbook. I'll show you the one that I have for you guys in the handbook. It looks like this. It's the little algebra twins, okay? Call them Gemma and Ameg, but this is in the packet if you want to share this with your students in the handbook. All right. So how do I use these algebra twins as I'm going along? Well, I just emphasize to my students that Gemma, that little straightforward child, is what we employ when we're simplifying. She's nice and simple. She obeys the symbols, and she's so well behaved. She always plays on her side of the fence. And that's my sum up for it. Whereas Miss Ameg, that's Gemma backwards, you guys, she's a little more mischievous. She uses opposites and she goes on both sides of the fence. She'll tunnel right over to the other side and play out of bounds. And so that's kind of my little trick to sum it up. And I have to admit that this is not um, original with me. I was at COABE, the National Adult Education Conference 2 years ago, and an educator from Ohio came and told me and said, "I use your thing, and I call solving a Meg because she uses Gemma." And so I said, "Can I steal that and use it?" And she let me. And now she's one of the board of directors on the nonprofit Light and Salt Learning. So there you go. It was the start of a beautiful relationship when she taught me about a Meg. But anyway, so Gemma's one-sided and a Meg's when we start crossing. Okay, hopefully that's a good summation and I'll help some of your students who like a word picture. Okay. One of the last things I want to talk to you guys about is a verbal script. So you may not have realized it, but you already heard me using it. So I'm going to go back actually to this one and model it. But every time I'm solving an equation, I use some really consistent language with students, and I will verbalize it even when I'm working with a skilled student. And even if they're doing it, I'll be verbalizing it. So you'll hear me say things like, all right, so take a look at this equation. Examine the left and the right hand sides. Is there any straightforward math, any simplifying you know how to do? So let's look at the left hand side. Yeah, that 3 is shoved up against those parentheses. That's multiplying. I know how to multiply a grouping by 3. I'll pass that out. 3 times x is 3x, and 3 times -5 is -15. And that's going to be equivalent to whatever I get on the right hand side. Let's take a look at the right hand side. Is there any simplifying, any straightforward math I know how to do over there? Yes, absolutely. I can combine those terms because they're like terms. X plus 7x is 8x. Beautiful. Examine the left-hand side. Is there any more straightforward math you know how to do there? Any more simplifying? Nope, those aren't like terms. I can't combine them. Take a look at the right-hand side. Is there any more straightforward math we can do? Any simplifying? Nope, absolutely not. 8x is alone. There's nothing else we can do there. Now it is time to start moving backwards, busting out a meg. Okay, notice though, do you see it? I see it. Do you see we have a problem? There's x's on both sides. First step, we need to get the x's to the same side. And I'll spare you guys the entire thing, but I use this language over and over and over again. And by this time, my students have heard a lot of it. And by this time we get to multi-steps, they've heard the parts that go to just this skill, just that skill. And so they're used to this. If it sounds like a lot to you, they've already learned parts of it. And now we're putting together this script. And I will do a lot of verbalizing for my students. So I would encourage you to have a verbal script as well, because even fluent students can suddenly find themselves lost in steps or lost in symbols. And that's especially prevalent, like we said, when they go to take the test. You can have a fluent student who knew what they were doing, went into test and froze. And that freezing is often because they are unable to navigate through the symbols because their anxiety is so high. And so if they have this verbal script, then they can start prompting themselves. And the joke is that they get your voice in their heads. And I always say that to my students. I'm like, I hope my voice is in your head when you go to test day. Sorry, not sorry. And students tell me all the time, Kate, I heard you in my head. I'm like, good, excellent. Now, hopefully you can get me out of your head now that you passed, you poor thing. So the key though is to use short, easily remembered phrases. Be consistent. Use the same phrasing over and over again. Um, don't suddenly flip it up, even if it's simple. You want students to be able to echo the verbal script, so they need to get to the point where they're internalizing it. So instead of you speaking it, they're speaking it. And I will encourage my students to speak out loud, especially when get the chance to work with them one-on-one. But even when they're working by themselves, you'll see some of my students mouthing it. But again, that's what we want. We want them to internalize that script. A repetition is crucial to memory, guys. And so it's important to continue that script into fluency. Even though they're fluent, even though they're solving fine, we're continuing to, I'll say like, here's a great example. So my student says, okay, I'm going to subtract 7. And I say, I'm sorry. My student will say something like, so, okay, I'm going to subtract 7 from both sides. And I'm like, awesome. And they say, and it cancels. I say, oh, adding 7 and subtracting 7 are opposites. They cancel. See, I just put that language in there. And then they say, okay, 3x equals 15. And now I'm going to divide by 3. And I'll say, what are you dividing by 3? Or they'll say, now I'm going to divide. I say, what are you dividing by? Like I'll prompt them verbally, even as they're competent, to make sure we know what's going on. Okay. Now you might say, Kate, that's a lot. That's a whole lot of verbal script. Oh my goodness. I'm not a math expert, and I don't even know where to start with that, and you already overwhelmed me. That's fine. I have what's called Mathability playlists for the entire subject of algebra. So I talked about for you guys on my website, we have all this free materials for you. Well, this is on YouTube. It is a playlist of Mathability videos to work with struggling students through all the different algebra subjects. And in each one of them, I teach the verbal prompt and I explicitly tell students at the end of the video, here's all the verbal prompts you should be able to prompt yourself. Take note of these, make sure you know them. You've heard me talk a lot. So, question, does anybody have any verbal scripts that they already employ in their classroom? I'd love to hear it. Give me a chance to breathe and sip my water, and you guys share with me in chat. Who's got a verbal script they already employ in your classroom? You don't have to give me the whole script. You can just give me a phrase or two that you find particularly useful. Rob says the prompting really helps. So, Rob, tell me a prompt or two. I love that. Dividing by the same factor gives you a one. Emphasis on the one. Nice, Kim. The seesaw of the equal sign. The seesaw of, I love it. Ooh, even better than a scale because everybody's been on a seesaw. Not everybody has been on a balance beam scale. Rob says, same as me, adding what? Dividing by what? To both sides? Yeah, they get irritated with you too. They're like, yes, I know. And I'm like, yes, I want my voice in your head. Anybody else got a good one before we move on? I love that, Kim. What you do to one side, and I'm looking for them to say, you do to the other, you do to the other. Nice, nice. They will hear the voices during testing. That's what we want, don't we, Wendy? We just want our little earworm voices in their head while they're testing. I do hope that they can eventually get my voice out of their heads. I do. Okay, awesome. Thank you, you guys. Anything to get them to remember on the test. Amen, Rob. Isn't that the truth? All right. So the essential skills of algebra. So we talked today about solving, but I'm just going to wrap up, since this is the last webinar of these sessions, what the three essential skills are. So first one is substitution. What is substitution? Replacing or trading out a piece of an expression or an expression, pardon me, for another. So, but they have to be equivalent. So trading one equivalent expression for another is substitution. And that is 75% of math. I mean, it's so huge. If you didn't get a chance to be part of that one, I highly suggest you go back and watch Essential Skill 1. Simplifying, which we talked about today, but we also talked about last time, which is performing that indicated operation in order to find the most compact equivalent form of an expression. So you're just putting things together. You're just doing that straightforward math, doing what it told you to do, making it as simple as possible. And then finally, that solving. And I'm talking about that isolating there, that using inverses to find the value of the variable that makes a statement true. Beautiful. And there is a ready-made integration of all three of those skills. Anytime you learn how to do one thing, it's a whole different thing to do that all by itself than to mix it up. We were talking about like going on the freeway. So if you want to put together substitution, simplifying, and solving all together, the great place to go is utilizing formulas. Just using GED formulas in general is all over the math. It's on the science. There's so many examples to play with, and they're very, very easily leveled because you have formulas of all different lengths and styles, and that employ different types of numbers. And so for a beginner, use those simpler formulas like P equals 4S or distance equals rate times time. Use only whole numbers. Just stick to whole numbers so they're practicing the substitution, simplifying, and solving. And use explicitly named shapes and measurements. So again, we're just honing in on the one skill, but you're telling them what the name of the shape is. You're telling them that this is the perimeter or this is the width. You're not making them do use their word problem interpretation skills yet. But as students gain that experience, we can start making things more complex and we can start introducing higher levels here. We can use more challenging numbers like fractions, mixed numbers, or negatives. Think of the slope formula with negatives. Now that one expert level, right? We can use implicit measurements where we didn't explicitly tell them what it is. For example, it just says how many square feet a room was, but it never states that that square foot is the area. So a student would need to have that background knowledge, that prior knowledge, to add that word problem interpretation skills to add to their algebra. We can use more complex formulas like volume of a cylinder, the Pythagorean theorem, the slope formula, the quadratic formula. The quadratic formula is probably the biggest expert level formula we have on the GED. And then another great way to up the game is to use those variable dimensions. What do I mean? I mean, like when, say, ask you to find the perimeter of a triangle, very simple skill, but suddenly students will start balking if I don't just have values for my sides, but I have variables on there as well. Even if the math is fairly simple to add those things up, now we're graduating where we're talking about using a formula, we're substituting in more complex expressions, and then we're having to use our simplifying skills. Like there's a lot going on. So by using variable dimensions, you can up the game as well. All right. Oh, you guys, it's a miracle. We finished early. And hopefully it's not because I'm talking too fast this time. But let's really quickly recap and then talk a little bit about what we're going to do in our classrooms. So, linear relationships, recap of what we talked about. Linear relationships have no exponent on the variable and they can be solved through inverse operations. We can solve multi-step linear equations and inequalities. When we put those skills together, it's a complex skill composed of simplifying expressions and using inverses to cancel variable terms and using inverses to isolate variables. And then students really need that structure and those navigational tools. So, yeah, 90% of basic algebra, 90% of what they need in the GED is those three skills: substitution, simplifying, and solving. Nice. Okay, you guys. So my last question to you, don't leave me yet, is what instructional strategies can you use to help students master the complex skill of solving? Drop that in the chat for me. I want to know which one of these instructional strategies we talked about, or maybe you have something you want to share with me, can we use to help students master solving? Kim, that verbal script. Yes, repeating your language consistently. Absolutely. I love that. Drawing a line and or blocking to simplify each side. It's game changing for some students. It's crazy how much that little line can help them. Yeah. I love that. Rob tells his adult learners that there are two kinds of equations to worry about on the GEDs, some to solve and some to draw. You're talking about those linear equations that they have to graph. Nice. Oh yeah, Mark, just making sure that they stay organized. They're all over the place. They don't know what skills to use when. Aaron, that's not something we talked about today, but yeah, uh, under, understanding integers is crucial to solving equations on the GED because it is so integral to understanding inverses, right? Um, and using think alouds to model each step. I love it. I love it. Aaron says writing big. Do you know that by just increasing the amount of space between each problem on a page, you can actually increase students' scores? That's right, just giving them blank space. So writing big, giving blank space. I tell my students all the time, I'm like, I love the trees, but if it comes to saving the trees or saving my students, I'm going to save my students every time. Give yourself space, use the paper. We've got the paper. All right, you guys. Um, Thank you so much for everybody for participating. You're amazing. We're going to put up a little poll on the screen. Please fill it out. Give them your feedback about today's training. And then while we do, I'm going to let you know about the next Wednesday webinar. So let me find that. Oh, my fingers are not working. There we go. Next Wednesday webinar is on March 25th. So in 2 weeks at 3 p.m. And it's called From Insight to Impact, Teaching with Adult Learning Theory. And you can go ahead and register for that on the IPDAY event calendar. All right, you guys, thank you so much. I so appreciate you. Good session. Thanks for participating.